Another property of our functions is to determine whether or not they are odd or even. We talked about odd and even functions some time ago when we first talked about polynomial functions. I hope you remember those definitions. Now let's take a look at these values for theta I have here. I first of all want to mark the quadrant for each of those. So here we're in quadrant 1, negative 60 degrees, quadrant 4, 120 degrees, quadrant 2, negative 120 degrees, quadrant 3. I also would like to mark in the reference angle for each of these. 60 degrees, 60 degrees. 120 is 60 degrees away from the x-axis. Negative 120 degrees is 60 degrees away from the x-axis. So I know that I'm using the same triangle or the same point on the unit circle for all of these answers. Fill in the values for sine, cosine, and tangent, and each of these values of theta. If you had difficulty with these, it means one of two things. One, you are not practicing enough. Remember, I'm asking you to do math for 1 or 2 hours every day. I'm sure that you're not if this is still difficult. The second thing is you should be getting help. Make an appointment to see me. Make an appointment to see another instructor or a peer educator. Get help from your friends. These kinds of questions should no longer be difficult. So do you remember those definitions for odd and even functions? I asked you several weeks ago to memorize these. I said we would use these definitions again when we got to trigonometry. Here we are. So even functions are those functions where f of x is equal to the f of negative x. Now, x in this case and negative x are going to represent our angle measure. They're going to represent theta. So we're looking for questions where the answers are the same even when theta is the opposite of each other. So if you look at these, can you see which function or functions might be even? I hope you see it here. Cosine of 60 degrees and cosine of negative 60 degrees both equal positive 1/2. Cosine of 120 degrees and cosine of negative 120 degrees both equal negative 1/2. Cosine is an even function. We can say that cosine and its reciprocal secant are even functions. So theta can be the opposite of each other, and the answer will always be exactly the same. Let's look at what's happening with sine. When I have a sine of positive 60, I have a positive answer. When I have a sine of negative 60, I have a negative answer. When sine is positive 120, I have a positive answer. When I have sine of negative 120, I have a negative answer. So I see that even when theta here is the opposite, my answers are the opposite. That's true for tangent as well. Opposite values of theta give me opposite answers. Sine and cosine are odd functions. Both sine and tangent and their reciprocals, cosecant and cotangent, are odd functions. So how do we use these rules? Well, because sine of negative 30 is equal to the negative f of x, it means I can move this negative outside of the function. So I don't, again, have to think about sine being in quadrant 4. I could find the sine of 30 degrees, which by now I hope you know is 1/2, and then say it's going to be negative. We move the negative sign outside. Tangent is also odd, so we're going to do the same thing with tangent. We're going to move the negative sign outside and look for the negative tangent of 60 degrees. We know that tangent of 60 degrees is 1/√3, and we can move the negative outside. This is negative √3/3. Sorry, I was thinking of 30 degrees. Tangent is √3, that's 60 degrees, and we put the negative outside. But cosine is even. So we can ignore the negative sign and say that the cosine of negative 40 degrees will give me the same answer as the cosine of positive 45 degrees. Cosine of 45 degrees, √2/2. In the next lecture, we'll do some more work with these periodic properties and odd-even properties of our functions.